Deep in the Gobi Desert, a facility resembles a space station more than a power plant. Chinese engineers have achieved what nuclear scientists have dreamed about for 70 years. On an ordinary Tuesday morning, their thorium molten salt reactor hit a milestone. This milestone sent shockwaves through the global energy community. For the first time in history, a nuclear reactor successfully refueled itself. It kept generating power without shutdowns or cooling periods. No massive industrial ballet of removing fuel rods was needed. The reactor just kept humming along, producing clean electricity. It continuously fed itself new fuel. Think about that for a moment. Every nuclear power plant needs to shut down for fuel changes. From Chernobyl to Fukushima, they all have lengthy shutdowns. It's like turning off your car to refill the gas tank. But China's thorium reactor refuels itself while driving down the highway. Here's where this story gets incredible. Traditional nuclear reactors run on uranium. Specifically, uranium-235, which is less than 1% of all uranium on Earth. Finding enough uranium-235 is like searching for diamonds in sand. Thorium is the opposite. There's so much that we don't know what to do with it. Mining companies treat thorium as waste since there's been nowhere to use it. China has enough thorium reserves to power their country for 20,000 years. 20,000 years is longer than human civilization has existed. But here's the crazy part. Thorium can't power a reactor by itself. It's like having wet wood that won't burn no matter how many matches you throw. You need to transform thorium first, and that happens inside the running reactor. The reactor literally creates its own fuel as it operates. Chinese engineers discovered how to make this process incredibly efficient. Their reactor produces more fuel than it consumes. It's a nuclear reactor that grows more powerful over time. The breakthrough isn't just about thorium. It's the design of the entire system. Traditional reactors are like giant pressure cookers filled with solid fuel rods. The water gets so hot it turns to steam, trapped under enormous pressure. If something goes wrong, that pressure can explode outward with devastating force. China threw out that entire design and started from scratch. Their reactor uses molten salt instead of water, heated to over 1,300 degrees Fahrenheit. The thorium fuel dissolves into this molten salt, creating a thick, glowing liquid. The brilliant aspect of this reactor is its ability to self-regulate. If it overheats, the molten salt expands, slowing down the nuclear reaction automatically. It's akin to a car that automatically reduces speed when the engine is too hot. In case of a serious issue, they can drain the molten salt into underground tanks. There, it cools and solidifies harmlessly. The laws of physics make it impossible for this reactor to experience a Chernobyl or Fukushima-style disaster. However, the most incredible breakthrough lies in how they handle the refueling challenge. Traditional reactors must shut down because their fuel is locked inside solid metal rods. Removing these rods and installing new ones is like performing surgery on a patient. You can't do it while the heart is still beating. China's liquid fuel system changes everything. Since thorium dissolves directly into the molten salt, they can add new thorium. They can also remove waste products while the reactor runs at full power. It's similar to changing your car's oil while driving on the freeway. The Chinese team developed a continuous processing system that resembles a sophisticated coffee filter. Fresh thorium flows in, waste products get filtered out, and the reactor never misses a beat. This single innovation eliminates weeks of downtime, making their reactors dramatically more efficient than anything else on Earth. Now, let's discuss the scale of China's plans, which are absolutely staggering. Currently, their test reactor produces 2 megawatts of power, enough for about 1,000 homes. That might not seem like much, but it's just the start of something bigger. By 2030, China plans to have a 10-megawatt demonstration plant operational. This plant will provide enough power for about 5,000 homes, but they're aiming higher. The ultimate goal is to establish 100-megawatt commercial reactors, each capable of powering 50,000 homes. These reactors will operate with zero carbon emissions and virtually no nuclear waste. Here's where it gets even more incredible. China intends to build dozens of these reactors, possibly hundreds. They're focusing on arid western regions first, like Xinjiang and Inner Mongolia, where water is scarce. In these areas, traditional power plants struggle to operate due to limited water resources. Remember, these thorium reactors require significantly less water for cooling than traditional nuclear plants. They can function in deserts, on mountaintops, and even in underground facilities. China is essentially transforming its most remote and inhospitable regions into clean energy powerhouses. Other countries are observing China's breakthrough with a mix of amazement and concern. The United States pioneered molten salt reactor research in the 1960s, but then shifted to uranium-based reactors. Now, American energy companies are racing to restart thorium programs that have been dormant for decades. India, which holds some of the world's largest thorium reserves, has announced a massive acceleration of its research program. They're planning to leapfrog directly to thorium reactors, bypassing the construction of more traditional uranium plants. Even European countries are suddenly taking interest in this new technology. France, which derives 70% of its electricity from nuclear power, is quietly funding new thorium initiatives. Thorium research projects are gaining traction. The UK is exploring thorium reactors as part of its net zero carbon strategy. However, there's a significant challenge. China currently has a 10 to 15-year lead in this technology. While other nations are still drafting blueprints, China has a functional reactor generating power and validating the technology. This groundbreaking development transcends clean energy. It has the potential to shift economic power globally. Countries that master thorium technology first will gain access to virtually limitless clean electricity. This means cheaper manufacturing, more efficient data centers, and unlimited desalination for fresh water. Industrial processes that are currently impossible with costly fossil fuel energy will become feasible. China is already strategizing thorium-powered industrial complexes for manufacturing steel, aluminum, and other energy-intensive products. These products will be produced at costs that no other country can compete with. Imagine facing economic competition from a nation with access to essentially free and unlimited electricity. The implications of this technology extend even further. Oil-exporting nations are watching with concern. Countries that have built their economies around fossil fuel exports could see a rapid decline in demand. The potential for this to happen is much faster than anyone could have anticipated. The engineering challenges that China faced in making this technology viable are astonishing. Molten salt at 1,300 degrees Fahrenheit is extremely corrosive, damaging most metals like acid. Chinese engineers had to innovate new materials capable of enduring decades in this environment. They engineered special alloys that create protective barriers when exposed to molten salt. These materials actually grow stronger over time, developing crystalline structures that resist corrosion. It's akin to armor that repairs and enhances itself under extreme conditions. The continuous fuel processing system required new chemical separation techniques to be invented. They had to extract specific radioactive isotopes from flowing molten salt while maintaining balance. One misstep could lead to the reactor shutting down entirely. Chinese scientists developed robotic systems capable of performing these precise operations. These robots function in extreme temperatures that would melt copper and in lethal radiation fields. They perform complex chemical processes beyond the scope of current industry standards. Perhaps the most remarkable feature is the reactor's accident-proof design. Traditional nuclear reactors rely on constant human oversight for safety. Operators must monitor numerous systems and make quick decisions to avert disasters. In contrast, China's thorium reactor employs what engineers term passive safety. The laws of physics inherently prevent dangerous situations from arising. If the reactor overheats, the molten salt expands, slowing the nuclear reaction. In case of a power failure, gravity automatically drains the molten salt into safe storage tanks. The reactor cannot melt down, as the fuel is already in a molten state. It cannot explode due to the absence of a high-pressure water system, nor release significant radiation. Traditional nuclear reactors generate radioactive waste that remains hazardous for 10,000 years, far exceeding recorded human history. This waste must be stored in specially designed facilities, monitored constantly to prevent environmental contamination. In contrast, China's thorium reactor produces waste that becomes harmless in about 300 years. While still a long time, 300 years is manageable within normal human timescales. More importantly, thorium reactors produce about 99% less waste than uranium reactors. The small amount of waste they do produce can actually be recycled back into the reactor as fuel. Chinese engineers are developing closed-loop systems where virtually nothing gets thrown away. Everything is reused until it's completely consumed, minimizing waste production. China's plan to deploy these reactors in their western deserts is strategically brilliant. These regions have been economic backwaters for centuries, too hot and dry for traditional development. However, thorium reactors thrive in exactly these conditions. They don't require water for cooling, making drought a non-issue. These reactors are small and modular, allowing for transportation to remote locations. They generate an immense amount of electricity, powering energy-intensive industries that would be impossible elsewhere. China plans to transform their least valuable real estate into their most strategically important industrial regions. They envisioned thorium-powered manufacturing cities in the deserts, connected by high-speed rail. These cities would also feature ultra-high voltage power lines linking them to the rest of the world. The global nuclear industry is scrambling to respond to China's breakthrough. Companies that invested billions in traditional uranium reactor technology now face potential obsolescence. International nuclear regulators are struggling to establish safety standards for thorium reactors. The technology is so different from traditional reactors that existing regulations don't apply. China is essentially writing the rulebook as they go, gaining immense influence over global standards. Some countries propose international cooperation on thorium research to avoid a Chinese monopoly. However, China has already invested heavily in thorium technology, making it difficult to catch up. Catching up would require nations to spend hundreds of billions over decades. China's timeline for scaling up thorium technology is incredibly aggressive. Their 10-megawatt demonstration plant is set for completion by 2030, just 7 years away. If they achieve that target, they'll demonstrate that thorium reactors can operate reliably at a commercial scale. The ambitious goal is to develop 100-plus megawatt commercial reactors. Each reactor would be a massive industrial complex, able to power entire cities. They would also produce hydrogen, desalinated water, and high-temperature industrial heat for manufacturing. Chinese energy planners are already identifying sites for dozens of these facilities. They're envisioning thorium reactor clusters that could generate more electricity than the Three Gorges Dam. This scenario raises fascinating geopolitical questions about energy independence and reliance on fossil fuels. Chinese thorium technology could influence international relationships for decades. Countries adopting this technology would rely on Chinese expertise and fuel processing capabilities. They would also depend on ongoing technical support from China. Alternatively, China could keep this technology to itself. Using their energy advantage, they could dominate global manufacturing. Imagine competing with a country that has near-zero electricity costs. In 7 years, when their 10-megawatt demonstration plant comes online, we'll know if this technology can deliver on its revolutionary promise. But here's the question that should keep every world leader awake at night. What happens when China starts offering this technology to other countries? Which nations will be chosen as partners, and which will be left behind? The decisions made in the next 5 years could shape global power for the next century. The thorium revolution has begun, and China just fired the first shot. This could become the most important technological race of our lifetime. Think this thorium reactor breakthrough is mind-blowing. Wait until you see what happens when China builds a bridge taller than the Eiffel Tower. We're talking about a structure so high that jets have to change their flight paths. The Millau Bridge in France was supposed to be the engineering limit. China just shattered that limit and built something 300 feet taller. Check it out right here.